Double disc brake system. I bought them because the bicycle brake power was insufficient. Wanted to buy Tektro dual caliper brake, but it's difficult to find. Non-drive side 32 millimeters.
Non-drive side to flange.
These are 32 millimeters symmetrical hubs.
Drive side to flange.
Flange diameter 58 millimeters.
Non-drive side flange diameter. Drive side flange diameter.
Hub axle width 110 millimeters.
Hub axle width.
Some rims have effective rim diameter information displayed. However, obtaining ERD information for most rims, including from the retailer or manufacturer's website, is difficult. This method is a measurement technique for cases where ERD rim information is not available. We will use gravity. We begin measuring the inner diameter of the rim from the valve hole. Insert the nipple onto the spoke in the direction of the head. Insert the nipple into the hole. Now mark the section where the nipple protrudes with a marker pen. Use vernier calipers. The measurement is 3.5 millimeters. Measuring the inner diameter of the rim becomes very easy. ERD equals 3.5 by 2 plus inner diameter of the rim. Add 7 millimeters. ERD is 553 millimeters.
Spokes racing pattern.
The spoke length calculation is complete. Install the spokes. Through axle adapters are required for the latest hub standards. This wheel utilizes the cross pattern, which is the standard method of inserting spokes into the flange by alternating left and right. It's a double disc hub. It's my first time too. You've seen a lot, haven't you? Stop watching YouTube. Shall we start wheel building? The spokes are ready here. Let's start from the front. We will be using the MTX39 rim. It's incredibly wide. It feels like a motorcycle rim. The width is astonishing. It looks like a fat bike. Most tires will probably end up being wide. I brought the spokes. This hub doesn't have a specific direction. Please install it like this. Jump one hole at a time. Next, let's check the spoke installation sequence. First, install the spoke from flange side A out to in direction.
한쪽 면만 이렇게 먼저 끼워주세요. 그리고 투크로스로 할 겁니다. 이번에는 세컨 점프 이렇게 네, 이렇게 패턴이 완성됐습니다.
Second step, flange. B. Fit the spoke inwards from the outside. Now
반대로
flip it over.
뒤집어서요.
Fit it next to the initially installed spoke. Install it closest to this side. Do the same,
이렇게 하나
jumping one like this.
점프하시고
Jump one hole at a time. Please install it like this. Install it next to the initially installed spoke.
옆자리에
Attach the nipple.
방향대로
Install it on the fourth hole. Done.
됐습니다.
Drive side pattern complete. Now, rotate the hub with the spokes installed in the opposite direction of the valve hole to create a cross pattern. Pay attention to the reverse valve hole. Don't rotate the hub like this. The point is to avoid the valve. Install from inside to outside. Move the spoke in the reverse direction. Cross the second spoke. Go inside with the last spoke. It goes here.
해줍니다.
This is the spoke overlap. When the bike wheel spokes cross, the last spoke that meets does not simply pass by, but needs to be overlapped and connected to make a sturdy wheel. Install the next pattern spoke as well. Flange side A back inside to outside. Third step, flange B. Fit the spoke outward from the inside. The front wheel doesn't require many crosses. Do a 2 crosses operation.
Yeah.
Done.
자,
One side pattern is complete. Finally, the fifth step is to install the spoke in flange A outward from the inside. Next, install the spoke here.
됐습니다.
Flange side B back inside to outside. Install all the remaining spokes in the empty holes. Install all in the empty holes. UFO.
그렇죠? 중심은 잘게
Hold the spokes and move. Two crosses.
넘어가서 이쪽으로 갑니다. 배치해 두고 이쪽도 됐습니다.
It's a pattern of jumping 3 holes with the spokes.
자, 마지막 스포크를 조립합니다.
The last spoke is number 36. The wheel pattern is finally complete. For modern standard hubs, a through-axle adapter is required. Using a spoke wrench, you should be able to determine the start and end of wheel rotation while tightening the nipples. Attach a sticker-like tag to the spoke next to the rim valve hole. To tighten the spoke nipple, turn it clockwise. Tighten all the nipples while leaving a 1 mm spoke thread. For beginners, it is recommended to use a spoke wrench. Start aligning the left and right sides while tightening the nipples. Firstly, we will explain the principle behind adjusting the rim left and right. By tightening the right drive side spoke nipple, the rim will move to the right. Conversely, tightening the left non-drive side spoke nipple will move the rim to the left. It is important to note that over-tightening the left spoke nipple can cause the rim to move too far. Releasing the nipple will cause the rim to move in the opposite direction. In summary, the principle is that the tension power balance of the left and right spokes moves the rim and aligns it to the center. For center alignment, tighten the spoke nipples. Aim for about 80% tension. Using a dishing tool during the process can save time. Check the left and right sides. 1 mm on side A, 1 mm on side B. Align left and right within a range of 1 mm deviation. Next, adjust the vertical alignment to within 0.5 mm deviation. Start the vertical alignment from the point of contact and increase tension. Secondly, let's take a look at how to align the rim up and down. By tightening the peripheral nipples together, the rim will move towards the hub. To move the rim in small increments, tighten or loosen the nipples at least 360 degrees. Loosening the surrounding nipples together will cause the rim to move away from the hub. Vertical alignment of the rim only works when the left and right spoke tensions are adjusted together. Currently, there is noise due to vertical rim deviation. Vertical alignment takes a long time. If tightening doesn't work, you need to loosen the nipple located inward. Aim for 90% tension, approximately 18 to 22 kg force. Be careful not to exceed the tension. Allowable deviation for vertical alignment is within 0.5 mm. When assembling wheels, the center can become slightly misaligned due to errors in the wheel truing stand. To correct this, a tool called a wheel alignment gauge, or centering gauge, is used. First, let's set up the dishing tool on the non-drive side. Attach the gauge securely without any gaps. Now, fix the gauge in place. Move the dishing tool to the opposite position. The measurement shows a gap of about 4 mm. To calculate the rim displacement distance, 4 mm division by 2 equals 2 mm rim displacement distance. Now, we only need to move the rim by 2 mm. Adjust the position of the rim by tightening the left nipple once and loosening the opposite nipple once. This will allow the rim to move without changing the tension of the spokes. Before starting the job, label the spokes and check the starting and ending positions to ensure accuracy. Start the inspection again from the beginning. There should be no gap on the drive side, and if the measurement distances on both sides are equal, the rim is perfectly centered. 1 mm on side A, 1 mm on side B.
자, 이쪽 똑같고요. 이쪽도
The measurement values on the left and right sides are the same. It is perfectly centered. We confirm the overall tension of the wheel spokes by hand. You can also perform a manual inspection like this. If you have a tension meter, feel free to use it. For 14-gauge spokes, the measured value should be between 20 and 25 kilograms force. Lastly, tighten or loosen the spokes by 90 degrees at a time for left and right alignment. We work with a tolerance of up to 0.5 millimeters for left and right alignment. For 14-gauge spokes, the measured value should be between 20 and 25 kilograms force. Premium rims have minimal vertical tolerance even in the welding area. The overall alignment of the wheel is complete.
얼라이먼트가
Success.
성공입니다.
Remove the through axle adapter.
대시 어댑터 뺍니다.
Great. Remove the tags.
이것도 빼버리고요. 좋습니까? 테이핑 작업을 했고요.
Install rim tape to prevent inner tube punctures. Now, you can install the tire.
PS.
Subscriptions, likes, and comments are greatly appreciated as they greatly support video production. Thank you for watching.